And would you believe I ran out of memory? And so here, we'll take the time to simply present to you the results that were obtained when I measured the pH for the various solutions. First, I have a pH of 5.76 for the deionized water. Again, reflecting the fact that the water has some carbon dioxide dissolved into it, which forms carbonic acid, the deionized water to pH below 7. Next, I have the pH of the formic acid as 2.37, that for the sodium formate, 8.37, and the formate buffer, a mixture of both formic acid and sodium formate, with a pH of 3.75. As I add 1 drop of hydrochloric acid, I expect to see the pH drop. And, suffice to say, it does in fact drop rather substantially when added to water to a value of 2.60. It drops when added to the formic acid, which, given the pH is low to begin with, doesn't change all that substantially. It drops to 2.21. It drops rather remarkably when added to the sodium formate. The pH changes from 8.37 to 5.22, but, and this is rather remarkable, when the acid is added to the formate buffer, the pH merely drops by 0.03 pH units, reflecting the fact that this buffer is resisting pH change. If I add a drop of sodium hydroxide to the deionized water, the pH jumps crazy amounts to 10.83. And when added to the formic acid, the pH rises as well. Note, of course, by adding the sodium hydroxide to formic acid, I begin to form a buffer. And perhaps that's why the pH doesn't jump all that amazingly. When I add sodium hydroxide to the sodium formate solution, the pH jumps by crazy amounts to 11.51. And yet when I add the sodium hydroxide to the formate buffer, it merely changes by 0.02 units. Again, reflecting the fact that buffers resist pH change. I hope you enjoyed this experiment. I know I did. Take care and continue to have fun in these crazy times.